This is a question from a grade 11 question paper where we have a chemical equation that is balanced, as you can see. And then these chemicals are actually quite unknown to us. What we have here is actually the formula for an antacid that is going to then cause the release of carbon dioxide. So let's just look at our questions. Write down the formula of the substance that causes the fizz when the antacid dissolves in water. So when the antacid dissolves, the only thing that is a gas phase is the carbon dioxide, which must be what causes the fizz, because only a gas can cause the fizz. Go and fart in the bathtub, and that will prove my point. Then it says a certain antacid contains 1,8 grams of H3C6H5O7 and 3,36 grams of NaHCO3. The antacid is dissolved in 100 cubic centimeters of distilled water in a beaker. Now, they love asking this question, define 1 mole of a substance. We know that a mole of a substance is this amount of substance having the same number of particles as there are atoms in 12 grams of carbon-12. But let's go back to our question and just check the next one. Calculate the number of moles of NaHCO3 in the antacid. So we have 3,36 grams of NaHCO3. When we have mass, we can take it to moles. This is the formula that we use. N equals mass over molar mass. Molar mass is the mass of 1 mole of this compound. You use your periodic table to calculate this. When we go and use our periodic table, Na has a mass of 23, H has a mass of 1, carbon a mass of 12, and 3 oxygens, 3 times 16. Just check if my math is still up to scratch. 3 times 16, 48, plus 12, 60, 61, 64, 84. 84 grams per mole. That is my molar mass. So when I go and substitute these values into my formula, 3,36 divided by 84, it is going to give me the following. 0,04 moles. NaHCO3. Okay, let's look at the next question. Determine using calculations which substance is the limiting reagent. Now we are going to have to look at both of our reactants here to figure out which one is the limiting one. I see I have 1,8 grams of H3C6H5O7. That's a mouthful. H3C6O5H7, is that correct? Let's just double check. Yes. No, H5O7. H5O7. Okay, so when we go and look at the mass of this substance that we have, I believe this is acetic acid, 1,8 grams. 1,8 grams, we can go and calculate the amount of moles that we have here as well. So let's go and calculate the molar mass for this funny looking substance, molar mass. We use our periodic table. 3 times 1, 3, plus 6 times 12, 72, plus 5 times 1, 5, plus 7 times 16. Let's go and figure this one out. 112 plus 5 plus 72 plus 3. 192. 192 grams per mole. Let's go and calculate how many moles we have. N equals mass over molar mass, which equals 1,8 divided by 192. This gives me 0,0094. 0,0094 moles. Okay, So what we need to go and do now is we need to go and check which one is the limiting reactant. So to do that, we first need to know what our mole ratio is. For every 3 NaHCO3, we have 1 H3C6H5O7. So the mole ratio here is 3 to 1. So when we use our mole ratio of 3 to 1, we know that we have 0,04 moles of NaHCO3. How many moles do we need of the other one? We multiply crisscross and we get 3x is equal to 0,04. And we divide this by 3 to get x on its own. And if I use my calculator, 0,04 divided by 3 gives me 0,01 moles. Okay, so I need 0,01 moles to react with all of the NaHCO3. I only have 0,0094, which means my limiting reactant here is going to be the acetic acid. This is my limiting reactant because I do not have enough of it. The limiting reactant is the one that determines the amount of product that forms. Let's quickly look at the next question. Okay, then calculate the mass of the reactant in excess. So the reactant that is in excess is my NaHCO3. Let's go and just open a new page. NaHCO3 is in excess. So if we have a look at how many moles we do have, we have 0,0094 moles here of the acetic acid. And we want to calculate how many moles of NaHCO3 we have. We know our mole ratio is 3 to 1. So when we multiply 3 times 0,0094, this gives me 0,0282. This is the amount of moles of NaHCO3 that we are going to use. So how many moles did we have to start off with? We had 0,04 moles. 0,04 is the amount that we have. We subtract 0,0282. And we are left with 0,0118 moles. That is in excess, which means we didn't use it, it didn't react, it's excessive. When we go and just double check our question here, remember we are trying to calculate the amount that we have in excess. This can then be converted back to grams. N equals mass over molar mass. Mass is going to equal N times M, where N's value is 0,0118. Molar mass we said is 84. And this gives us 0,9912 grams of NaHCO3 that did not react. Right, so this combines moles, limiting reactant, and determining what is in excess all in one question.